and last up today, if you have a velocity time graph, the area between the line and the axis is the displacement of the object. Now, I'm going to say for this one that positive is going to be the forwards direction and negative is going to be the backwards direction. So I've got an object that's travelling at 2 meters per second, so that's 2 meters per second forwards for 10 seconds. And it's not realistic because then it instantaneously changes direction to 2 meters per second backwards. So that's a velocity of minus 2 meters per second. And it does that for another 10 seconds and then instantaneously it stops. Okay, so if I'm doing 2 meters per second forwards for 10 seconds, then I've gone 20 meters forwards. So my displacement for that time is 20 meters. And then if I go minus 2 meters per second for another 10 seconds, my displacement is minus 20 meters, which we know means 20 meters forward and 20 meters backwards. So all together here, my total displacement, so at 20 seconds, my total displacement is 0. I'm right back where I started. So generally, you don't have to be going at constant velocity for this to work. A general principle is that the area between the axis and the line is the displacement. If the line's above the axis, then this area is displacement, so that you've moved forwards. And if it's between the axis and a line that's under, then you've moved backwards, or whatever your directions are here. And by adding them together, you can get the total displacement for the journey. Okay, time for a great big practice question, pulling together several things about velocity time graphs. So this one, yeah, my printer's broken, but if you download the PDF, you can get the proper exam question, which you really need for this one because you do have to do calculations and you have to actually draw the graph. Okay, so it says the following figure shows the velocity v of a ball against the time t as it falls vertically from rest to when it hits the ground at A. So here's rest, 0 velocity. So you let go of it here and it falls vertically until it hits the ground at A. So that means that positive is downwards in this graph and negative is upwards. Okay, and the exact coordinates of A are 0.58 seconds and 5.8 meters per second. Okay, so the first part of the question says, use the figure to show the distance that the ball falls is approximately 1.6 meters. 2 marks for that. I'll give you a little time to do that now. Okay, so remember that displacement is the area under the line for a velocity time graph. So you want to turn this into a triangle. I'm not going to draw it because I need to draw there again in a second. But if you put a line down here, vertical line to make a triangle, what's the area of that triangle? And that will be the displacement. But remember, distance is just the size of the displacement. So it will also be the distance. Okay. Then it gets much more interesting. It says, part B, the ball is in contact with the ground for 20 milliseconds and then rebounds vertically with an initial upwards velocity of 5.1 meters per second. We're going to skip the next part of the question, part I, but we are going to do part II. So that says, sketch on the figure above, so sketch on the graph, the velocity against time graph for the ball after it has bounced off the ground until it reaches its maximum height. So basically, continue the graph until the ball gets back to its maximum height. 3 marks. Good luck. Okay, so the ball's in contact with the ground for 20 milliseconds. That's 0.02 seconds. So it's that little bit of time there. So the ball hits the ground at 0.58 seconds, travelling at 5.8 meters per second downwards. And then at 0.6 seconds, it's going to leave the ground, travelling at 5.1 meters per second, but that's 5.1 meters per second in the other direction. So that's minus 5.1. 5.1 upwards, minus 5.1, and that's at 0.6 seconds. So try and get this reasonably accurately. It's about there, say. That's when it leaves the ground. Now you don't have to draw in the time it's in the ground. It's touching the ground, but I'm going to just so it's clear. So very, very steep line there. So that's while it's in contact with the ground. And looking ahead, that's actually a very steep acceleration in the upwards direction, which is due to the ground pushing the ball upwards. Okay, but the bit we're going to get marked on is the next bit. So then leaves the ground travelling at 5.1 meters per second upwards, and then it's going to slow down until it's back to zero velocity at its maximum height, and the gradient needs to be 10 meters per second squared downwards. So that needs to be positive direction is downwards, so that's going to be positive 10 has to be the gradient. And that, of course, is the same gradient as this part of the graph. So I'm going to sort of cheat a little bit and just try and draw it parallel, so that looks about right. There we go. So this needs to have a gradient of plus 10 because plus is the downwards direction. Well done if you got that one right.